class 8. Moving on to the next portion of matter, that is states of matter. You know that there are three states of matter: solid, liquid and gas. Now I am going to explain what is the basic difference. You can see here the structure of atom in a solid. See, they are very tightly packed. That's why the interparticle attraction is very high in solid. This is structure of atom of a liquid. See here the gaps, intermolecular space or gaps of the in between the atom are, you can see. Okay, and that is the reason why interparticle attraction between the atoms in liquid are less than a solid. And this is gas. Here you can see there are so big gap, long gap between the atom. So here the interparticle attraction are more or less. Okay, and they are tightly packed. They are not so much tightly packed, and they are very loosely packed. This is the reason why solid are having fixed shape and fixed volume. Liquid have fixed volume but do not have any fixed shape. They take the shape of the container where we put it. And gas do not have any fixed volume, do not have any fixed shape. Next, look at the book. The differences between solid, liquid and gases are given here. Okay, just go through it. What are the properties? Volume, solid having fixed, liquid having fixed, gases do not have. A shape, solid have fixed shape, liquid do not have fixed shape, gases do not have fixed shape. Fluidity, solid cannot flow. As you know, solid cannot flow, but liquid can flow as they are loosely packed, less rigid than a solid. And gas, yes, they are able to flow very easily. There is no rigidity between the atoms. Arrangement of particle, as I told you, they are very tightly packed. Liquid loosely packed and gases are very loosely packed. Okay, so go through this. Next we are coming to the point latent heat. Or before that we need to discuss the energy involved in change of state. If we take a piece of ice, we keep it in normal temperature, that is more than 20 degree. We know that temperature of ice is less than 0 degree. Okay, so next, if we keep it in normal temperature, what will happen? It will be melted and the solid shape will change into the liquid shape. So what we need to change from solid to liquid, it is required that temperature or heat is required. So if now if without changing temperature a solid is converting into liquid, or a liquid converting into gas, or vice versa, gas converting into liquid, liquid converting into ice, that heat is known as latent heat. See, it is given here. When a substance undergoes a change of state without any change in temperature, it is called latent heat. Next come to latent heat of fusion. What is the meaning of latent heat of fusion? It is the amount of heat absorbed or released when a substance changes from solid to liquid or from liquid to solid without any change in temperature. Just a simple example take. Ice piece, we are keeping it normal temperature, it is changing into water, isn't it? So we are not giving any extra, it is not changing its temperature, just heat is required. So this is known as latent heat of fusion. The specific latent heat of fusion of ice is 336 into 10 to the power 3 joule per kg. This is very important. What is the meaning of this statement? That means 1 kg of ice, if absorbed 336 into 10 to the power 3 joule heat energy, then it will change its states from ice to liquid. Okay. Next, latent heat of vaporization, that is, it is the amount of it absorbed or released to change the substance from liquid to vapor. When we are boiling water at a certain temperature, when we are giving a certain heat, at a certain point it starts vaporization. So the heat absorbed by that matter, that is known as latent heat of vaporization. What is the specific latent heat of vaporization of water? That is 2260 into 10 to the power 3 joule per kg. Next, this is also very important. What is the meaning of the statement? That 1 kg of water absorbs 2260 into 10 to the power 3 joule of heat energy to change into water vapor. Okay, so go through this portion. Next day we are going to discuss about the advantages of latent heat. Thank you, class.